Welcome to Workplace HSE Explained, your go-to channel for clear, practical, and engaging safety insights. Here, real workplace hazards, OSHA-inspired topics, near misses, and prevention strategies are broken down into simple, easy-to-understand lessons. Whether you work in construction, warehousing, manufacturing, oil and gas, logistics, or even an office environment, every video helps you spot risks faster, work smarter, and stay safer. If you care about hazard awareness, safety culture, incident prevention, and protecting people at work, you're in the right place. This is Workplace HSE Explained, where safety becomes simple. It takes just 0.2 seconds for electricity to stop a human heart. That's faster than a blink, faster than a thought. And that's exactly how one worker lost his life. Not because of bad luck, but because of a chain of ignored hazards and missing controls. This is the story of a fatal electrocution that happened in less than a quarter of a second, and today we'll break it down using HIRA, Hazard Identification and Risk Assessment, to understand what went wrong. Picture this: a maintenance electrician walks into a production area to replace a faulty motor. The machine had stopped suddenly during operation, and the supervisor wanted it fixed fast. "It's just a quick job," someone said. "No need to shut down the whole line." Those words sealed his fate. The electrician opened the panel. The indicator lights were off. He assumed the circuit was dead, but assumption is not isolation. He didn't verify with a tester. He didn't lock out the supply. He didn't tag the breaker. He simply reached in with a screwdriver to check the terminals. And in that instant, 0.2 seconds, 440 volts surged through his body. The current entered through his right hand, traveled across his chest, and exited through his left arm. His muscles locked. His heart fibrillated. He collapsed instantly. The shock was so fast that no one around him realized what had happened until he hit the floor. Coworkers rushed forward, but none were trained in electrical rescue. One tried to pull him away, barehanded, and received a secondary shock. Another ran to cut the power, but didn't know which breaker controlled the circuit. By the time help arrived, it was too late. The electrician was gone. This tragedy wasn't caused by electricity alone. It was caused by a breakdown of safety fundamentals, a failure of HIRA, because every electrical job carries predictable hazards, measurable risks, and controllable outcomes. But when those steps are skipped, even routine maintenance becomes deadly. In this series, we'll break down the incident step by step. Part 1, the story and the moment of failure. Part 2, hazard identification, what dangers were ignored. Part 3, risk assessment, how the controls collapsed. Part 4, lessons learned, how this death could have been prevented. Electricity doesn't forgive mistakes. It doesn't wait for second chances. It reacts instantly. And that's why understanding HIRA isn't paperwork. It's survival. Stay with me as we uncover how a simple quick fix turned into a fatal 0.2-second disaster. To understand how this electrocution happened, we must start with the first step of HIRA, hazard identification. And the truth is, the hazards in this job were not hidden. They were obvious, predictable, and well-known, yet they were ignored. So let's break them down in a way even a beginner can understand. The first hazard was live electricity. Electricity is invisible. You cannot see it, smell it, or hear it. That's why workers often underestimate it. But the human body is a perfect conductor. When current flows through the body, it follows the easiest path, usually from one hand to the other, passing directly through the heart. Even a small amount of current can be deadly. At just 30 milliamps, the heart can go into fibrillation. At higher voltages like 440 volts, death can occur almost instantly. This hazard was present the moment the electrician opened the panel. The second hazard was stored energy. Many people think turning off the switch is enough, but electrical systems can store energy in capacitors, cables, and motors. Even if the machine looks dead, it may still hold dangerous voltage. Without proper testing, you never know what's live and what's not. The electrician assumed the circuit was dead because the indicator lights were off, but lights can fail, bulbs can burn out, indicators can malfunction. The hazard was still there. The third hazard was absence of isolation. Lockout Tagout, LOTO, is designed to eliminate electrical hazards by physically disconnecting the power and locking it in the off position. Without LOTO, anyone can accidentally energize the system. In this case, the supply was still live, no breaker was locked, no tag was placed, no one verified isolation. The hazard remained active. The fourth hazard was contact with exposed terminals. When the electrician reached inside the panel with a metal screwdriver, he created a direct path for current to travel. Metal conducts electricity extremely well. The moment the tool touched a live terminal, the current found its way into his body. This hazard was predictable and preventable. The fifth hazard was lack of PPE. Insulated gloves, arc-rated clothing, and dielectric footwear are designed to protect workers from electrical contact. But the electrician wore none of these. He was dressed for routine maintenance, not electrical work. Without PPE, the body becomes the conductor. The sixth hazard was poor supervision and pressure to hurry. When workers are rushed, they skip steps, they take shortcuts, they assume instead of verifying. The supervisor's push to fix it quickly created a psychological hazard, one that often leads to fatal decisions. Safety and speed never mix. The seventh hazard was untrained coworkers nearby. When the electrician collapsed, the others panicked. They didn't know how to respond. They didn't know how to cut power. They didn't know how to rescue safely. Their lack of training turned one hazard into multiple hazards. And finally, the eighth hazard was lack of a risk-based permit system. Electrical work requires a permit that forces the team to identify hazards, test circuits, isolate power, and verify controls. Without a permit, the job becomes informal and dangerous. That's exactly what happened here. These hazards were not hidden. They were not complicated. They were not unusual. They were simply ignored. And when hazards are ignored, risk becomes deadly. In Part 3, we'll move to the next stage of HIRA, risk assessment, where we analyze how each hazard increased the likelihood of a fatal outcome and how every control failed in sequence. Now that we've identified the hazards, it's time to move into the next stage of HIRA, risk assessment. This is where we evaluate how dangerous each hazard is, how likely it is to cause harm, and how exposed the worker is. And in this case, every risk rating should have been high, critical, or unacceptable. But because no assessment was done, the electrician walked straight into a deadly situation. Let's start with the most obvious risk, contact with live electricity. The severity here is fatal. Electricity at 440 volts can stop the heart instantly. The likelihood was high because the circuit was never isolated, and exposure was direct because the electrician reached inside the panel with a metal tool. When severity, likelihood, and exposure are all high, the risk becomes intolerable. No work should proceed until controls are in place, but the job continued anyway. The second major risk was absence of lockout tagout. Without LOTO, anyone could energize the system accidentally. A coworker could flip a switch. A machine could auto-restart. A breaker could reset. The severity of unexpected energization is fatal. The likelihood increases dramatically when LOTO is skipped, and exposure is constant because the worker is in direct contact with the equipment. This risk alone should have stopped the job. The third risk was assumption-based decision-making. The electrician assumed the circuit was dead because the indicator lights were off. But indicators are not reliable. They can fail, they can burn out, They can give false readings. The severity of relying on assumptions is extremely high. The likelihood of misjudgment increases under pressure, and exposure is total because the worker is unprotected. This risk was invisible but deadly. The fourth risk was lack of PPE. Without insulated gloves, arc-rated clothing, or dielectric shoes, the human body becomes the conductor. The severity of shock without PPE is fatal. The likelihood increases when working inside a live panel. And exposure is direct because the worker's hands are inches from energized parts. This risk should have been unacceptable. The fifth risk was poor supervision and time pressure. When workers are rushed, they skip steps, they take shortcuts, they ignore procedures. The severity of rushing electrical work is extremely high. The likelihood increases when supervisors push for speed, and exposure is constant because the worker is performing a hazardous task under stress. This risk is psychological, but just as dangerous as physical hazards. The sixth risk was untrained coworkers nearby. When the electrician collapsed, the others panicked. One tried to pull him away and received a shock. Another didn't know which breaker to turn off. The severity of untrained rescue attempts is high. The likelihood is high because instinct takes over, and exposure is high because rescuers act without protection. This risk often turns one fatality into two. The seventh risk was absence of an electrical work permit. A permit forces the team to slow down, identify hazards, test circuits, isolate power, and verify controls. Without it, the job becomes informal and dangerous. The severity of working without a permit is high. The likelihood of missing steps increases, and exposure is total because no controls are verified. This risk was organizational and systemic. When we combine all these risks, the outcome becomes predictable. A fatal electrocution was not just possible, it was inevitable. Every risk pointed toward the same conclusion: the job should never have started. In Part 4, we'll complete the HIRA breakdown by examining the missing controls, the correct procedures, and the life-saving lessons every workplace must learn. And we'll close with the final message that could prevent the next 0.2-second tragedy. We've identified the hazards, we've assessed the risks. Now we reach the final stage of HIRA, risk control, the step that could have prevented this death entirely, because electrical fatalities don't happen due to electricity alone. They happen when controls are missing, ignored, or bypassed. So let's break down the exact controls that failed and how each one could have saved a life. The first missing control was proper isolation using Lockout Tagout. LOTO is not a formality. It is the single most important control in electrical work. When done correctly, it physically disconnects the power source, locks it in the off position, and tags it so no one can energize it accidentally. If LOTO had been applied, the circuit would have been dead. The electrician would have been safe. The fatal 0.2-second shock would never have occurred. The second missing control was testing for absence of voltage. Every electrician is taught one rule: test before you touch. A simple voltage tester used for 5 seconds would have shown that the circuit was still live. But because the electrician relied on indicator lights instead of a proper tester, he walked into danger blind. Testing is not optional. It is mandatory. The third missing control was use of proper PPE. Insulated gloves, dielectric shoes, and arc-rated clothing create a protective barrier between the worker and electrical energy. Even if accidental contact occurs, PPE can prevent current from entering the body. But the electrician wore none of these. He was dressed for mechanical work, not electrical work. Without PPE, the body becomes the conductor. The fourth missing control was barriers and insulated tools. Live panels should never be accessed with bare hands or metal tools. Insulated screwdrivers, insulated mats, and protective covers reduce the chance of accidental contact. But none of these were used. The screwdriver created a direct path for current to flow. The fifth missing control was supervision and job planning. A supervisor should have ensured that the job followed procedure, that LOTO was applied, and that the electrician was not rushed. Instead, pressure to fix it quickly created a shortcut mindset. When speed becomes the priority, safety becomes the victim. The sixth missing control was training for nearby workers. When the electrician collapsed, the others panicked. One tried to pull him away and received a shock. Another didn't know which breaker to turn off. Proper training would have taught them to cut power first, use a non-conductive object, and avoid direct contact. Untrained rescue attempts often turn one fatality into two. The seventh missing control was an electrical work permit. A permit forces the team to slow down, identify hazards, verify isolation, test circuits, assign roles, and prepare for emergencies. Without a permit, the job became informal and unsafe. The absence of a permit removed every layer of protection. And finally, the eighth missing control was a strong safety culture. A culture where workers feel pressured to hurry, where shortcuts are tolerated, and where procedures are seen as obstacles will always lead to tragedy. Safety culture is not about posters or slogans. It is about behavior, accountability, and leadership. So what are the lessons from this 0.2-second tragedy? Never assume a circuit is dead. Never skip lockout tagout. Never work without testing. Never enter a panel without PPE. Never rush electrical work. Never attempt rescue without cutting power. And never forget that electricity reacts instantly, long before you can. This death was preventable. Every step had a control. Every control had a purpose, and every purpose was ignored. The result was a life lost in less than a quarter of a second. If this video helped you understand electrical hazards better, share it. Someone else's life may depend on it. And if you work around electricity, remember, safety is not a suggestion. It is a responsibility. This is Workplace HSE Explained, reminding you to stay alert, stay trained, and stay alive. Until next time, take care and work safe.